Now in number 5, we're trying to figure out if this triangle is acute or obtuse or right, because we don't have any kind of markings with those angles. So we set this up as if we're comparing the legs to the hypotenuse in the Pythagorean theorem, as if it was a right triangle, and we're trying to see if those are actually equal. Then it's right. If one side is larger than the other, then we know it's not right, and it's going to either be acute or obtuse. So the first thing we need to really do is figure out if this is right, what's the hypotenuse? And so this square root of 194, you might need to do a little bit of work on that, and you recognize as you plug that in your calculator, that's about 13.9. Okay, so that is the longest side. So if this is right, that would be your C side, your hypotenuse. And so we're going to set up our Pythagorean theorem, a squared plus b squared equals c squared, although we got kind of a question mark. Does it really equal or not? And if we find out that it's equal, great, then it's right triangle. If we find out that this side's larger, then it's going to be acute. If we find out that this side of the equation is larger, then we know it's going to be obtuse. Okay, so let's plug this stuff in. For A, I'll put this side of 3, and we have to square it. For B, I'll put this side of 13, and we have to square it. And then again, we've got kind of this question mark equation. Is it really equal to what would be my hypotenuse of square root of 194 squared? Okay, so let's now do the algebra with that. 3 squared is 9. 13 squared is 169. And the square root of 194 squared is 194. Okay, again, are those two things equal? Doesn't look like it's going to end up being that way. When I combine the left side, I get 178. And when we compare that to 194, we see that this side is bigger. It's not equal. So the longest side squared by itself is larger than the other two sides squared. Therefore, this is an obtuse triangle.